Thank you all for coming. My name is Anand Srinivasan. I'm a senior tech analyst here at Bloomberg Intelligence. My colleague is Mandeep Singh, also a senior tech analyst at Bloomberg Intelligence. We're a group of about 300 or so analysts providing data, believe it or not, and research and analytics on a multitude of industries on the Bloomberg platform for professional investors, corporates, a ton of data, a ton of analytics on there. Feel free to check it out. So I want to talk a little bit about the depth of data, the volume of data, and the variety of data. Mandeep's going to do a stage setting, if you may, talk through a bunch of topics on that issue, and then I come out for the fun stuff, which is to talk about specifically use cases. And with that, I will leave it to Mandeep.
Great. Thanks, Anand. So I want to start off with this slide simply because it puts everything in context. We hear a lot of buzzwords, trends, big data, cloud, AI, blockchain. And I thought it was important to size up these markets just so that we know what we are talking about. So if you see on the slide, cloud is a little over $100 billion market. Big data is somewhere close to $50 billion. And all of the markets, security is another big one, and AI and blockchain are relatively small. The point of this slide is that if you look at big data and cloud, these are the two established trends. If you look at the big data market, it's growing around 12 to 13%, which is 2 times the total IT spending growth. And we're talking about 1.5 trillion in IT spending, so it's a much bigger number. But clearly, everything is moving to cloud, and big data is one of the enablers of AI, blockchain, the new technologies. So it's important to keep the numbers in mind, and really the nexus of cloud and big data is what is driving a lot of the change. So if on this slide, you will see a lot of the big data growth will be on cloud. We are talking about growth rates of 27%, which is 4 times the on-premise growth rates for big data. So essentially, if you keep big data and cloud in mind, you're going to see a lot of disruption in the form of AI, in the form of newer technologies. Every mega trend, be it digital transformation or you name it, AR, VR, leverages some form of big data and cloud. So next slide. This essentially, when I talk about big data, I think it's important to put it in context that a lot of big data is generated from machines. And when I say machines, it's coming from sensor devices, it's coming from logs that are being generated by servers, it's coming from weather patterns, it's coming from, you name it, social media, stuff like that. So a lot of the data is machine generated, and the relational database, which was essentially used for the transactional data, doesn't work anymore for the machine data that gets generated. So it's really important to see the trend around non-relational data, which is generated primarily from machines and feeds, and you can see the growth in non-relational data. And I'm not saying relational data will go away, but it's very important to keep in mind what big data is and where that data is being stored. And non-relational data is how it's getting sifted through, how it's getting searched. So really important context with non-relational data. Now this actually shows the spending by vertical. So you are going to see a lot of applications of big data in manufacturing and banking, and we have already seen that. That's what makes up that 50 billion market. And just for the record, that 50 billion doesn't include services. So you have this entire services ecosystem built around that 50 billion of big data products. So manufacturing and banking are leading the way, but the other sectors are also heavy investors in big data. And finally, this kind of sums up what's happening with the data. Because of all this machine-generated data, you are seeing the data growing at 25%, which essentially means your data will keep doubling every 3 years. That's what it means. And now we are talking about the importance of big data and how once you have large data sets, that is essentially the fuel for AI. So the other side of big data, I guess, one is that the amount of data generated continues to increase. The other is the cost of storage continues to go down. And we all know about Moore's law. We keep hearing that. But this is, I mean, both on the SSD side, on the hard disk, the cost of storage goes down. And it makes sense. That's what will drive this wave of innovation, because you don't have to pay up for commodity storage. The other big trend is, servers. Obviously, our chips are more powerful. There is diversity in, the kind of servers that are available. You keep hearing about GPUs, so TPUs. Essentially, now we have servers for the kind of workload that, we need the servers for. So we don't need to throw CPUs at everything. In case of, autonomous vehicles, for example, there is a lot of graphic processing involved. And in that case, GPU is a much better chip to use. So the point is that the server spending will increase. I mean, it will increase in line with the IT spending. But the accelerated server spending is the specialized servers that, GPUs and the TPUs, they are going to grow much faster. And then finally, on the edge side, obviously, edge is a very important aspect, because you can't do everything on the cloud. When you look at server and these GPUs, TPUs, they will primarily be deployed on the cloud once that becomes the de facto platform. But on the edge, you need to do a lot of things on the edge, and autonomous vehicles being a big example of, how the edge is very important. So you need that kind of computational ability on the edge, and so that's going to drive a lot of analytics as well as the growth in chips on the edge side. So I thought this is really important just to understand, the whole wave around big data and cloud. At the end of the day, is to drive productivity, is to drive, improvement in businesses. And how AI actually taps a lot of this data is machine learning works off of large data sets. We all know machine learning has been around for a very long time. But the reason why it's making such a big splash and impact now is because you have these large data sets, the big data sets that are being generated from logs, the sensors, the weather patterns, that can be fed into those machine learning algorithms for classification and just for prediction. So we have already seen that big use of AI in banking, fraud detection, and stuff like that. And retail, I mean, Amazon's business is built around the recommendation system, is built off of big data. So manufacturing is another big one. And healthcare, we think, I mean, based on our estimates, is going to be the next big sector where the combination of cloud, big data, and AI can be really disruptive. So moving on, these are other AI use cases, more horizontal than vertical. So you can see how chatbots and just video-based systems, recommendation systems, the preventative maintenance systems. These are some of the examples of AI that are very popular. But what's enabling all this is this combination of cloud and big data, and really the large data sets that companies are able to curate out of the machine data. That's what is driving that. And the next one, this is more voice-based, but I think what I want to leave you, in terms of the combination of these technologies is cloud and big data are solving a lot of problems. And now the way the problems are being solved is through AI. So when I see, we analyze a lot of companies, we analyze a lot of technologies, the biggest use of cloud, AI, and big data is in solving the security problem. And when I say security, it covers the gamut from, fraud detection to even companies which deploy security. They have to aggregate the user behavior. They have to contextualize everything. They have to figure out where are the anomalies. And looking at the relational database, the transactional data is just not sufficient. So that's where the non-relational data comes into play. And now, not only is the big data, the machine-generated data, it's actually the videos and the audios and the images. So that's where voice is on the rise. You look at all the surveillance videos that are being captured, from different types of systems. And those can be fed into a big data system. And you can actually glean insights, classify that video and the audio data. So very important. We think the next wave of growth, given the deployment of these devices, the Amazon Echo, Google Home, is going to be on the voice side, because there is a lot of big data being generated out of those systems. And it's very important to capture that, analyze that, classify that, and do some predictive analytics off of that. So with that, I'm going to let Anand talk about the cool use cases around IoT, which is the other big application of big data, cloud, and AI.
Thanks, Mandeep. So again, to summarize what Mandeep talked about, big data is voluminous. Big data has variety. Big data coupled with cloud can give us a tremendous amount of insight, particularly when you put analytics and AI on top of it. But I haven't been this excited about earth-moving equipment since I was 5. So this is why I say I come back for the cool stuff. So this is Caterpillar, okay? So how can Caterpillar, I watched through how large companies, arguably slower moving companies, I mean, we have very distinguished company representatives in the room, from Amazon to Uber to Google. My point is that we've seen all of the examples, and perhaps we live those examples on a daily basis. But Caterpillar's example is interesting, perhaps more down to earth. And the point here is they have a system called Cat Connect, right? And here is, they take into account data like from GPS, simplistic stuff, relatively simple stuff. GPS will help you flatten out areas of Earth that are in a more accurate way. They will know where to dig more effectively. No more line markers, no more manual labor, perhaps dangerous labor, in order to potentially flatten Earth, dig Earth, move Earth. Simplistic stuff. So that's one part of it. The other part of it is predictive analytics. A significant portion of Cat's business is on parts, okay? Now, you would argue that predictive analytics, for them, predictive analytics helps them prevent breakdowns, so their customers who are buying Caterpillar's earth-moving equipment can help them reduce breakdown, reduce time wastage, off time, et cetera. Now, one of the things that you could argue is, okay, if I'm a customer and this is going to help me replace parts, you can actually, you can avoid downtime. And that's the benefit for you. You don't have to wait on parts, on a specialty part that's stuck on back order for several weeks at a time. As a result, you have more uptime with your parts. And if you're a contractor and you own this stuff, you can have higher utilization and you make more money. It's a very simple value proposition, but a very powerful one. Another example, Epiroc. Now, this is a twofold. Obviously, utilization is a big deal. Asset tracking is another part of it. Efficiency of your tools and of the machinery is yet another one. But one of the things that also is a big cost factor in a mine is labor, right? So to the extent that you can automate some of this stuff is valuable. And it helps save lives, helps make the mining process more efficient and more lucrative. So yet another example where heavy earth-moving equipment. Precision agriculture, yet another one where you can, the row command technology can help you more efficiently till land, efficiently use less seeds for the same amount of land, and have better yield, have better efficiency of the use of equipment. So these are highly different examples relative to what we've seen from Amazon, what we've seen from Alexa or Google. But again, seismic improvements and very lucrative as well for the client and for the company itself in terms of small adoption of what we would think as very simple technologies. So predictive analytics, again, on both the new engines, which are loaded with more advanced sensors, which will tell you where perhaps shear is unusual or where there is more wear and tear relative to a different part, helps you with replacement, helps you with better analytics, helps you with more uptime, less replacement time, less downtime, but also we saw the example with the augmented reality where a technician can go in and potentially do checks on the wings, on the engine, simplistic checks on the engine, perhaps avoiding a costly replacement later in time. I want to close out with the fact that this is incredibly valuable. Having this data at this volume of data, this variety of data, this depth of data at our fingertips, coupled with the technologies that we didn't have before, coupled with the cost of technologies falling as rapidly as they are, this is a pretty incredible convergence. It is allowing us to do stuff far more aggressively, far more effectively, and it's lucrative across the board. Thank you all very much for your time, and there's more stuff on Bloomberg Intelligence. Thank you very much.
Ladies and gentlemen, please welcome to the stage Bloomberg's Gabrielle Coppola.
Hello. Before we get to the next portion of our program, we're going to have another poll for you. We want to hear from you. First off, thinking about the auto industry, connectivity, automation, electrification are transforming this industry, and it won't be long before the first self-driving car services go from being in the headlines to showing up in cities and on the streets. So please take out your clickers. We want to know what you think. When do you expect to see fully autonomous, level 5 vehicles on public roads? So truly autonomous, not just highways, but can do everything just like a human driver. When would you expect to see that?